Hey guys, at a large university, the chairperson of the mathematics department wanted to determine if there was a difference in how females perform on a math exam with respect to how males perform on a math exam. So it seems like it's going to be two samples. She asks one of the professors who has a large lecture hall with many students taking a math course to randomly select 8 females and to randomly select 12 males from his course and to perform a 95% confidence interval for the difference females minus males of the GPA. Okay, so it's going to be two samples and it's going to be 95% confidence interval. So this is the data that I have, okay? So there's going to be 8 females. Let's do this. 8 females. Their average was 97.25. with a standard deviation that's really small, 3.65. And the males, there were 12 of them, average 87.25 with a standard deviation of 9.60. Remember that this is an S, which automatically tells us that this is going to be a T. I'm going to be given, so this will have to be information that you know. So confidence intervals, guys, 3 steps. The first step is going to be our conditions. So let me pick green. Step 1, conditions. A dot plot shows no unusual pattern and no outliers in either graph. Both females and males were randomly selected as stated with the stem of the problem. Great. Step 1, you must do it for both N1 and N2, okay? So now, step 2 is going to be our formula. Our formula will always be statistic plus or minus critical value times the standard deviation of the statistic. Standard deviation of statistic, okay? So, with that being said, we have to decide if it's a 1 sample or a 2 sample. We already know that it's a 2 sample. So, you're going to see difference of sample means or difference of sample proportion. It'll be difference of sample means. And now the problem said female minus male, and they probably said that because 97.25 is bigger than 85.25. You want to work with positive numbers. Plus or minus critical value, so it's going to be a T, and then it's going to be times the square root of S squared female over N of female plus S squared of male over N of male. And we're just going to plug these numbers in, okay? So it's going to be 97.25 minus 87.25 plus or minus this critical number times the standard deviation, which is going to be 3.65 squared over 8 plus 9.60. Please use your formula sheet. This number here, we have two n's. Take the smaller n and minus 1 for the degrees of freedom, okay? So we're going to have to press second, vars, inverse t, okay? The area, do you guys remember from the last, so you're going to have area, degrees of freedom, the area. So they want a 95% confidence interval, which means there's going to be 0.025, okay? So to be honest with you, I did not look up this number. I totally forgot to do that. But you just look up, you put the area to be 0.025 and your degrees of freedom to be 7, the smaller of the two. And then the smaller of the two ends minus 1. You just put that there. Then you come here and you go stat, test, and you're going to go to 0, 2 sample t interval, 97.25, and its standard deviation, and the n, 87.25, 9.612. Confidence interval, never pooled, because remember, pool means that we know the standard deviations of the population, and we assume that they're the same. So once we press enter, we get here. So now we get to our interpretation. Now this is the important part for the interpretation, okay? Because it's 2 samples, we need 2 sentences. The first sentence is, based on these samples, okay? Stay with me. We are 95% confident that the true average, or the true difference in the average, the true difference in the average, and then you could put like this, you remember females minus males, is between 3.49 and 16.51, let's say, points. That's your first sentence. It's just the general sentence, okay? The second sentence is, if anybody remembers, you want to see if zero's in the interval or out of the interval. So 0 in this case is out of the interval. 0 is somewhere here, right? So it's not in the interval. So your second sentence, let me write here. Since 0 is not in the interval, there appears to be a significant difference. Okay, let me come up here. Significant difference. In other words, we think that females score higher on exams than males by anywhere between these 2 points. So another thing you might read sometimes is that since this only contains positive values, that's the same thing as saying 0 is not in the interval. So since 0 is not in the interval, there appears to be a significant difference in the average score between the 2 groups. Okay? So that's how you do a two sample t interval for averages, the confidence interval. So step 1 will be always the conditions. Just show it for both, okay? So show this for both, for either graph and for both. Step 2 is the formula. Please use your formula sheets. And remember how to find this t number, okay? Second vars inverse t, and you put the area there. Degrees of freedom is going to be n minus 1. And then step 3, after you put all this stuff in, you just interpret this number. Now, if it had negatives and positives, then 0 would be in the interval, and then you would say, oh, you know, it doesn't appear that females score better than males, or if there's a difference, because sometimes it's negative, sometimes it's positive. I should emphasize that this should be at the alpha equal 0.05, because this is for a 95% confidence interval, which means there's 5% alpha left. Okay, so that's how we do this. Take your time, slow down the video, pause the video, take notes, do whatever you need to do to make sure that you understand how to do this.